Good afternoon, everybody. So I'm the one who's like between you and the lunch. Is this a session? And this is a topic on warehousing. As you know, we just started to add warehousing WMS solution as part of the OTM site. What we have here is a real life story of a customer who had WMS working in their warehouse for a long time. But as the industry was growing, they felt a lot of limitation in their existing solutions and the technology which they were using. We came in as an advisory partner and provided some of the solution which was native to the WMS capabilities like wave picking, putaways, dashboards, etc. But also enabled them, so they implemented a Honeywell AR system, ARAS system. We of our legacy of our parent company, CK Builder Group, where we have done a lot of those manufacturing automation. We had built that domain technology, so we have the capabilities to integrate WMS with a PLC and MHE. So we built that integration where it uses WMS to move those batteries and packs, both from the storage system into a conveyor where it could get into a set of 2s, 4s, 6s, as well as retrieve them. So I'll walk through the solution a little bit more. Okay. Just a quick introduction. I lead the supply chain Oracle Cloud practice at Birlasoft. My responsibility is all logistics, warehousing, manufacturing, planning, and we do a lot of work in the whole logistics and warehousing. So we're going to spend just a couple of minutes on Birlasoft overview, and then I'll jump into the case study that we implemented, and then some of the slides of the lessons learned. As we go through this journey, we felt some of the things were important to highlight, so that should be incorporated if you are thinking of doing similar kind of an engagement. So we are part of a CK Builder Group. It's a fairly old organization in terms of it's been around 160 plus years with 35,000 employees. What is important is it has its own manufacturing and facilities around 30 countries, and we are around these three major segments. One is automotive and manufacturing. We do a lot of those gear manufacturing. It also has a home automation system built in within that. We are big into education and healthcare. We run hospitals and large schools and education institutes, and we are also into technology. And Birlasoft is part of that technology arm of that of the CK Builder Group. With this legacy of having their own manufacturing facility and the emphasis on Industry 4.1 is very important to us, because anywhere you have those big manufacturing, supply chain and industrial manufacturing, logistics, warehousing and automation are an integral part of that. Okay. So that has led to, we have this Birlasoft. I'm part of this organization which is Birlasoft, which is what we call is a technology and the digital arm of this of the CK Builder Group. We do work across advisory, platform implementation, a lot of AI work across the globe, Americas, APAC, EMEA, so across all time zone. Oracle and JD, these are our big, so we are one of the largest JD implementer, and Oracle is one of our biggest service segment. So we are a $635 million company, and 40% of the revenue comes just from Oracle and JD Edwards. Okay. The key takeaway I'll say that is that we have the scale, credibility, and ability to execute a global transformation project. We are also one of the go-to partners of Oracle, specifically in the OTM, GTM, and WMS space. So we have been part of this OTM SIG for a long time. We have our own solutions. So B Supply Connect is our control tower for end-to-end visibility. It has an agentic AI-based event tracking system. We also have a 3S smart spot bidding solution. We'll have a case study with Unilever today afternoon, where Unilever using OTM and our 3S, the smart spot bidding solution, how it has benefited a lot, especially during COVID and the post-COVID area. We have also got a WMS Lite solution. This is a mobile solution for an organization which doesn't want to implement an actual WMS solution, but they have Oracle inventory, and they want to use this mobile-based handheld to do the most of the warehousing operations like receiving, put away, or inventory transactions like moving sub-inventory transfers or cycle counting, issuing, picking up. All of that can be done through this WMS Lite. And these are all iPad, iPhone, or Android phone capable. And we have built this solution which integrates using the REST API with Oracle inventory. Yeah, sorry.
Sure. I mean, that's also the standard product, right? If you look at Cloud ERP, they also have a mobile version, right?
Sure. So the mobile version, it's like you have to open a browser, log in. What we have built is an app which can connect. So that app is using an Ionic platform. You can download it from iStore and Google Play.
Okay. That's the benefit.
Yeah. Yeah.
Okay. No, just to understand.
Yeah. So the Oracle has a mobile thing. You open a browser. In that browser, you log in and you connect to that. This is more app. It has buttons that way.
Okay.
We have built the UI very specifically. It's very user-friendly in an iPad kind of an environment. We are also, we do advisory, implementation, managed services across all of these services, right from warehouse management, trade management, landed cost management side of it. We have made partnerships with some of the key vendors like 4Kites and Project 44 to enable customers who have got OTM, GTM, and then want to connect with such a visibility and tracking solutions. With that, I will transition into the case study where this client of ours did this transformation using Oracle WMS Cloud. So this is a large EV battery manufacturing business. So they are primarily, originally was into diesel engine manufacturer, but with EVs, advent of EV, they have also started a new power business unit, which was primarily around EV and electric powertrain manufacturing. So the reason for they wanted to get into this transformation was, so they are moving into a high volume production. They wanted to be ready for an automation, and as they were growing into a large scale manufacturing, they wanted to make it sure that they are able to scale up to that volume. As I mentioned, this has gone through a multi-phase approach. So they had implemented Oracle Cloud from an old ERP system, which included the whole financials, supply chain execution, planning, and warehousing. That was phase one. So initially, the warehouse management solution was pretty vanilla. So they did the whole, when the sales order to picking to shipping out, we integrated to both LTL and as well as partial shipment to shipping out. We also implemented the standard putaway, receiving putaway, but the picking was more of a standard task generated. In the phase one, wave picking was not enabled. Then eventually, as that warehouse and the manufacturing facility started expanding, the need was, they felt there was a limitation in terms of how much they could scale up. So a couple of things happened. So they decided to implement a Honeywell-based ARS system, and also wanted to ensure that system was executed through this WMS Cloud. So before we implemented these, some of the limitation which was there, so they had a limited real-time inventory visibility issue, causing reconciliation between what was there in WMS versus what is there on the floor, what is there in the ERP system. There were a lot of manual put away and receiving. So when it came, some of the items needed to be inspected, some not. The designation of, they call it runner, repeater, and stranger, fast moving versus slow moving, not identified properly in terms of what needs to be put away, where it can be easily retrieved versus what needs to be put away in a back rack, so that it's a slow moving item. So that kind of a mapping and automated recommendation of put away was not there. The picking was based on the task was generated to and given and assigned to a worker without really looking at holistically what are the total number of picking that needs to be done in the day on the shift. There were also a cutoff of by 4 p.m. the truck needs to leave. So there was a lot of ad hoc adjustment was done to those tasks and the labor in terms of what needs to be picked. So that caused limitation in terms of what could be effectively picked during that time. There were some conveyor belt which is already there, but it was just to move material from one location of the warehouse to the shipping location. There's not an end-to-end automation there. And as it was rapidly scaling up, the leadership decided that the way that it was being run, it's not going to be able to support the future volume. So all of this led to deciding upon this transformation. And some of the key 3 solutions that we implemented, one is system directed put away. So we started building dashboards of fast moving runner, repeater, stranger, identified locations which are where the fast moving runners were kept versus where the repeaters and the strangers were kept. We put rules so that anytime they did a receiving, they tells you where to put based on what type of item that is. Then we also implemented for some of the especially for the runner, the wave picking side of it. So based on what's going to be the whole volume that needs to be picked away for that day, by a forecourt of time, we group the orders into a wave picking so that at one go the person can pick up the goods in a cart and then put it into the shipping bay. And finally, the one topic that I want to focus upon is that this integration with this Honeywell system with WMS Cloud. So the way it was done was we used OIC as a middleware which orchestrated between the WMS Cloud and the Honeywell system. So the task was published by WMS Cloud through RESTAPI. So you could use JSON or XMLs. The middleware translates and orchestrated messages and converts into what the PLC can understand. So move, pick. All the location information is mapped between what the PLC understands as a location versus what the WMS location understands it. And once the task is executed by the PLC, the system stores it or retrieves it. The feedback goes back with the task ID. We ensured that the mapping of what task ID, etc., passed on to the message back to WMS, so WMS understands and keeps track of whether it has been completed successfully or it's been a failure. Just a step down, the way the process flow works. So, for example, it could be a task, say, put away task which was has been executed at the WMS side. The middleware converts this into the protocol that the PLC understands. Once it receives, the PLC receives the commands, it then drives the MHE devices accordingly. Once it executes, whether it is moving or lifting or sorting the goods, so that the PLC then sends a kind of a feedback back signal that it has completed the task back to the MHE, sends it back to PLC. PLC tracks that status with the task ID and sends it to the middleware. through the middleware, then the WMS is updated, whether it's a success, failure kind of. So end-to-end, this process coordinates between WMS Cloud, the middleware, PLC, and MEC. So each of them has a specific role to play, and each of them has a very distinct responsibility of what each of them perform. And the way we have defined is we've gone through the design process to say, what task needs to be done, go through this process, what task needs to be manually done. So that's a initial design discussion that we had to happen. Secondly, there was a lot of debate and where to put the business rules. So some of the business rules can be put in the WMS system, can be put in the middleware. But the guiding principle is, as much as you should put it in the WMS, because that's the heart of what it drives it. There are some business rules can be put on in the middleware side. For example, if there are 10 tasks which is released and you want to group them into one single PLC command, that grouping can be done at a middleware level. Okay, so at the end of the day, it led to some high improvement in terms of the business outcomes. For example, there was a higher throughput and a faster fulfillment. It also had a higher picking productivity. So instead of a manual task and adjustment being done where each task was individually picked, we put together a wave picking, which led to a high level of picking productivity. Inventory accuracy, less manual error of what to sort, where to put using this Honeywell system. And there were a lot of elimination of the manual bottleneck, and that led to higher inventory count, inventory cycle count, faster movement of the goods, and ability to achieve that 4 p.m. cutoff time to ship the goods out. For the LTL and FTL, that's a 4 p.m. time. Parcel shipment could happen all through the day, but that truck of 4 p.m. was met. I'll have a couple of slides on some of the lessons learned. So one of the things that were really important was who does what. So the responsibility of WMS was it decides and tracks and executes. The middleware role is to orchestrate and coordinate. The PLC executes and the MHE moves. So those are the 4 distinct segments and we ensured that when we designed the system, each of them has their role to play and do not interfere into each other. The business rules, as I said, was primarily defined in WMS, and as much as possible, we tried to use the standard APIs of Oracle, and there are Oracle API guide, which I embedded over here, that really provides you a lot of information on what you can use and minimize the number of custom solutions that you need to build. The error handling side of it was very important. We wanted to ensure that any point of time, if there is a error, it immediately goes back and tells you whether any job is held. The design has to be in a way that if it stops, it still needs to know, it can then still resynchronizes with what has been done and where it needs to resume. There is many model of way to integrate, so whether to use event-driven and synchronous model. It's important that you give a task to the middleware and the middleware put a task to PLC. It doesn't wait for a response. It's an asynchronous kind of an integration that helps in making sure it moves smoothly. One of the important thing is that the way the ARS system defines each location would be different from what your WMS system knows that solution. So you need to ensure that that mapping between how a location or a locator into WMS is identified into the PLC system. And that reference table, mapping table, typically lies in the middleware layer. Okay. Finally, because it's a lot of automation, there's a need for a safety protocol. The primary driver of safety should remain at the PLC and the MHE equipment. So there should be areas where you can say, I'll manually force it to stop it, or if there are some conditions achieved that needs to stop it, it's driven through there. It's also recommended to have this is a continuous heartbeat monitoring between the PLC and the middleware, just to see if the connection drops, it then triggers. So there should be a constant polling between these two to make sure it can work. Those were the key main lessons learned. If I have any questions, I will take it up